guys remember that we were doing exponent law and we were doing how to isolate, at the beginning of the unit, we were doing how to isolate for the equation. Remember that? Doing like opposite operation, moving things from one side to the other side. Then we moved to the exponent law. And then I said that the reason we're doing exponent law is because we're going to get to exponential equation, so we can isolate for the exponent. Do you guys remember that? I told you that? Maybe not, because it's been almost 4 days, 5 days. So we're getting to that. Right now, we're getting to exponential equations. We're getting to how can I solve an exponential equation. Okay? We remember that if I had something that looked like this, and you want to isolate for x, you just do simple opposite operation. Divide by 3, then square root. Right? So this was easy because your base is the variable. But what happens if I have something that looks like this? How can I isolate for my variable? Well, my variable is in the exponent. Right? That's what we're trying to figure out today. How can I find what x is equal to if y is equal 324? So if I have this, how can I find what x is equal to?
Two methods. So by logarithm, or by to find.
Okay, so she said logarithm. How many of you know what logarithm is? 2 people. Right? And that's if you have a lot of math background. All right, what's the other method?
Try to find the number 324. How to find 2 plus something to get me this. No. So the power of 2.
2 to the power of something.
Of something to give me this. So
Yes.
To make it, both of them are the same.
How many YouTube videos have you watched over there?
Lots of videos. Lots.
All right. Good. I'm happy. Good. Okay, and then she said is, what Sharon said is, change this to make it as a base of 2. So 2 to the power of what? Sit down, use your calculator and start punching. 2 to the power of this, 2 to the power of this, 2 to the power of this, until you get to 320. So these are the 2 methods that we can do. One method, which is the logarithm method. Technically, it's not covered in the grade 12C curriculum, but I'm going to teach you how to do it because it's going to save you a lot of time. I won't be testing you on it, but then if you're stuck, try to use it. Okay? The other method, how many do you guys have your calculator in front of you? Can you find the log button? Log, L-O-G. Right? That is the logarithm. And the logarithm is the opposite operation of exponent. You know how square and square root are the opposite operation? Right? The log is the opposite operation of the exponent. So if I wanna get rid of that exponent, if I wanna bring that exponent down, I actually do the log. That's the opposite operation. Now we're gonna get into the whole lesson. This is just an introduction to the lesson. You might not find 2 to the power of whatever. What did you find?
8 something.
8 point something, right?
Divide, not multiplication, not dividing.
Okay, we'll get to that. We should jump into the end of the lesson already.
I'm just asking you.
All right. Now,
No.
let's define what's an exponential equation. So an exponential equation is an equation that contains a variable in the exponent. Can you guys give me an example of an exponential equation? Two to the power of x. 2 to the power. Yeah. All right? So that's an exponential equation, right? Because if you see, your exponent is a letter. It's not a number. Are we okay with that? All right. Now, some exponential equations can be solved without technology by writing both sides of the equation to the same base. Okay? So what does that mean? 2 to the power of x equals to 8. I can put both sides of the equality as a base of 2. So that means I can change the 8 to a base of 2. 2 to the power of what gives me 8? 3. 2 to the power of 3. So basically, I can write this as 2 to the power of x equals 2 to the power of 3. I did not change anything. My equality is still the same, right? But I wrote it in a different way. Okay? Now, when you see this, you see that the base is the same for both of them, right? Since the base is the same for both of them, that right away makes your exponent exactly the same. So if I'm saying 2 to the power of x equals 2 to the power of 3, so I right away make x equal to 3. Does that make sense to you?
Sorry, quick question, Maya. For your midterms, anybody in your class whose marks have been sent to OCAS and I need to add marks on, they need to come and let me know.
Okay.
Thanks.
And I will send my midterm mark today.
Yeah, no worries.
Yeah.
Thank you.
No problem. So if anyone applied to colleges and they need their midterm mark to go to the college, you need to go let the office know. Okay? So if anyone applied to the college to start in September and they need their marks to go to the college, you have to go let the office know. Now, so this is one of the easiest one of the easy ways to solve, right? It would work if my numbers are perfect, okay? So if I have 8, if I have 32, if I have something that's a multiple of 2, right? 2 to, it's 2 to the power of something, right? It's easy. Then I can use my calculator, I can do the math, and then try guess and check, guess and check, guess and check until I get the answer, right? So here's the formula. So the formula says, if a to the power of m is equal to a to the power of n, right, since I have the same base, then that right away makes m equals to n. Does that make sense? Now, the only time that this does not work if a is equal to 1, right? Because 1 to the power of 10, what is it equal to?
1.
How about 1 to the power of 30? How about 1 to the power of 52? 1, right? So in this case, the exponents are not equal to each other, right? Even though they're giving me the same answer. So that's why I can't, as long as a is not equal to 1, right? Then this will work. So a has to be greater than 0, where a cannot equal to, and a has to be positive as well, the base. Since 4 to the power of x and 4 to the power of 3 are both powers of 4, the exponent must be equal. So, look here. I have 4 to the power of x equals 4 to the power of 3. Because I have the same base, that right away makes my exponent equal to each other. I drop the base, make my exponent equal to each other, then x is equal to 3. Anyone have any problem with this? I can't read your faces. It's too early in the morning. Yes. You're having?
Yeah.
Okay. Look at this, Olivia. All right, when you read this, read it for me. It's 5 to the power of x? Okay, so you're saying that 5 to the power of x is equal to 5 to the power of 6, right? Because you have the same base, right? For it to be equal, for the two sides to be equal, right? Since you have the same base, since this is the same, then that right away makes these two equal to each other. Because I have that equal sign right here, right? Right away. How can I make these two equal? What's 5 to the power of 6? On the calculator, can you find that for me? It's a big number. So that's 15625, right? For me to be able to make this side 15625, I have to replace the x with a 6, right? Because I want both sides to be 15625, right? So if I replace the x with a 6, then that's going to be 15625, right? So that means x is equal to 6, right? If your bases are the same, that means your exponents are the same. Okay? So right away, when you see something like this, 5 to the power of x equals to 5 to the power of 6, then right away you can say that x is equal to 6 because my base is the same. Now, if your bases are not the same, you have to make them the same. Okay? So in this case, I have 2 to the power of x equals 32. So I have to make this 32 as 2 to the power of something. So you're going to use your calculator. You're going to start plugging in numbers. 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, until you get 32. So what is it? 2 to the power of 5. So now you see, I wrote them as both sides as a base of 2. So that means x is equal to, what does that mean? X is equal to 5. Now you can check your answer here, right? You can take 5, put it here, 2 to the power of 5, put it in the calculator, and that should give you 32. How about the next one? How can I make the right side as 2 to the power of something?
By switching the fraction to regular correspond to perfect number.
And
So
then
then
how do I do that?
half give me 2 to the power of negative 1.
Or I can multiply both sides is 2. So I have 2 times 2x equal 1. Because I have this formula. If I have the 2 base, I can add it, the exponent, the power. So I will have 2 plus x equal 1. 1 is
No, in this case,
1
we
is
do
2 over 0. Because
No,
Any
that's going to
number.
become too complicated though, right? Yeah, I know what you mean, but that's going to become too complicated for them to realize that 1 is 2 to the power of 0. But I know what you mean.
yeah.
That would work too. So, if you look at this, what's the power on the 2? What's the power on that 2 here in the bottom? It's 1, right? So because I don't want it to be in the bottom, I want it to be in the top, right? So what I'm going to have to do is I'm going to have to switch it. And we learned that when we switch, we change our signs from positive to negative, or from negative to positive, right? So I can write this, instead of 1 over 2, I can write it as 2 to the power of negative 1, right? Yes? Okay, so that means that 2 to the power of x is equal to 2 to the power of negative 1. Right? So what's x equal to? Negative. Remember, you want the same base. That's your goal. same base on both sides. So what would my base have to be here? 2, because my base on the left side is 2. Okay? Now, in order for me to change this base, that's going to be 1 over 2 to the power of 2. Now, what do I need to do right now to make them both as a base of 2? Flip it, and that's going to be what? Yeah. So 2 to the power of x equals to 2 to the power of negative 2. Now you see I have the same base, so I can drop the base and make my exponents equal. So that means x is equal to negative 2.
Actually, this part I did twice. 2 steps.
You can do it.
Yeah.
2 steps. How about E? What do I change? 49 as what?
7 over
7 to the power of 2. Why do I want it as a base of 7? Because you want the same base, and the left side is a base of 7, right? So then, now you see that I've changed both sides to the same base. Now that right away makes my exponents equal to each other, right? So now I can drop the base and make my exponents equal to each other. Now there's some more work involved here, okay? Because it's not only x, it's 3x minus 4. So there's going to be more work to do, yes?
Is it always to the power of 2 because now we have 2 sevens, or is it 2?
No, it's just I have to figure out, because the base here is 7, right? So I'm assuming that this base here has to be 7, okay? Because I want the bases to be the same. So now on the calculator, I'm going to have to do 7 to the power of something to get 49.
So we're starting with 2 and we're going to keep.
Yes. So you're going to try 7 to the power of 2. Because you right away get 49, you stop, right? And then you change the 49 as 7 to the power of 2.
Oh.
Okay? Are we okay with that? All right. Now, because I have the same base, I can drop the base and make my exponents equal to each other. So that means 3x minus 4 is equal to 2. Are we okay with this step? Okay? Drop the base, make the exponent equal to each other. Now, how do you isolate for x? What do you do?
move the r to the other side.
Move
Instead
what?
of the 4.
Move the negative 4 to the other side as a plus 4, right? So you're going to do opposite operation. So that's going to be 3x equals 2 plus 4. And then, yeah, then divide by 3, right? So x equals 6 over 3, which is 2. Now here's a question for you. If I put 2 here, let's see. So I'm going to check my work on the side. So I'm going to put 2 here. So I have 7, 3 times 2 minus 4. And let's see if the left side is equal to the right side. 3 times 2, that's 6. Take away 4. 6 take away 4, that will be 2. And then if I put 7 to the power of 2 in the calculator, that's going to give me 49. So since my left side is equal to my right side, that means my work is right. Okay? So this is how I check my work. Do I have to do it every single time? You can do it on a separate piece of paper, unless I ask you to check your work. Okay? I don't need to see this on your test or on your assignment or on your whatever, right? This is side work. common base that you want to work with on in the next one? 3. So you're gonna have to replace 81 with 3 to the power of something, right? Okay. What did it turn out to be? 4? All right, so we're gonna change this to 3 to the power of 4. So you see now, I have both sides with the same base. What can I do now? Drop the base, make the exponents equal to each other. So that's going to be 2x minus 4 equals 4. So I'm going to bring the negative 4 over as a plus 4. And then divide by 2. So x equals where did I get what? Yeah, because I had 2x equals to 8. I have 2x equals to 8, right? I want to get rid of the 2, so I divide by 2 both sides, right? Because I'm bringing it, yeah. All right, take some time to do the next 2 questions. Actually, you know what? No, let's do them together. What would be my base for this? 3. So I'm going to have to change the right side to make it as a base of 3. 3 to the power of what gives me 27? 3 to the power of 3. Good. So eyes on me, please, because this is where a lot of mistakes happen. Remember that you have 27 to the power of x, right? So there is that power of x that you can't get rid of. Okay? So what I did is I changed 27 to 3 to the power of 3. But that x is still there. Okay? So what happened here is I had a 27, so I'm gonna show you something here. So I had a 27 to the power of x, right? I changed that 27 and I made it 3 to the power of 3. See what happened? Okay. Now, what do you see here? Yeah, power to the power, right? Now, power to the power, what's the law there? Multiply, right? So that means I have to write this as 3 to the power of 5x plus 8 equals to 3 to the power of 3x. Are we okay with this? Now I have the same base, so what do I do with it? Knock it out, drop it, and then make your exponent equal to each other. Now you see that I have more than one x, right, term? So I want to make sure that the x's are on one side and the numbers are on the other side, right? So that means you're going to bring the 3x to the left, and then you're going to bring the 8 to the right. So that's going to be 5x minus 3x equals to minus 8. Are we okay with that? So that's going to be 2x equals negative 8. And then divide by 2. So that's going to be x equals negative. your work for this, right? Because this is one of the harder questions, I would recommend to check your work. So if I'm gonna check my work here, I do this. So 3, 5 times -4 plus 8 equals to 27 to the power of -4. Okay? So that's going to be 3, 5 to the power of -4, that's, sorry, 5 times -4, that's -20, plus 8. So that's going to be 3 to the power of -12. And now, you can enter this in the calculator. It's going to give you a pretty small number with lots of decimals, right? Or you can change the 27 as a 3. And then use your exponent. So that's going to be the power law. So that's going to be this thing. Okay? Checking your work, you can do that. Well, this. I'm gonna stop the video, and I'm gonna get you to get in a group and discuss how you're gonna solve this. Okay, how might you solve the next question? All right, and then try to solve it, and then we will take it up along with the last question.